Since the Apollo 17 capsule returned to Earth in 1972, human spaceflight has been confined entirely to low Earth orbit. We've spent over 50 years circling our own planet without stepping further out into the solar system. Breaking out of that orbit requires an enormous amount of vertical power. To push humans all the way to the Moon, and eventually Mars, you need a vehicle that can carry a far heavier payload against Earth's gravity well than any existing commercial rocket. That specific mechanical problem is what the Artemis II mission was built to solve. It's a 10-day, 690,000-mile test flight designed to validate NASA's new heavy-lift rocket under real deep space conditions. This puts the most powerful rocket ever constructed through a total, unforgiving stress test. At 322 feet tall, the Space Launch System, or SLS, weighs 5.74 million pounds when fully loaded with cryogenic fuel. At the base of the core stage are 4 RS-25 engines. These are the exact same engines that flew on the Space Shuttle, heavily modified with extra insulation to survive the extreme thermal environments of this new configuration. When those 4 engines fire alongside the 2 solid rocket boosters, they produce a combined 8.8 million pounds of thrust. Clearing the launch tower is incredibly violent. The sheer acoustic energy creates shockwaves that ripple through the air, while the exhaust forms intensely bright mock diamonds below the nozzles. That raw, overwhelming brute force pushes the Orion crew module completely out of Earth's atmosphere. Once Orion hits the vacuum of deep space, brute force becomes entirely useless. You can't just keep burning fuel. Survival now relies on precise orbital mechanics. This 3D vector graphic shows what we call a free return trajectory. Instead of burning heavy fuel to slow down into a lunar orbit, the spacecraft is aimed to loop tightly around the Moon and let gravity sling it right back to Earth. By hitting the lunar gravity well at the exact right angle and speed, Orion acts like a marble rolling down the curve of a bowl. It picks up momentum as it swings behind the far side of the Moon. Gravity takes over completely. The spacecraft coasts in total silence for 10 days, entirely eliminating the massive risks and fuel penalties of an orbital insertion burn. Keeping 4 humans alive during that long coast falls entirely to the European service module attached to the capsule. It generates the power, purifies the water, and provides all the breathable air. At the very apex of this figure-8 loop, the Orion capsule drifted exactly 252,756 miles away from Earth. That specific distance officially breaks the all-time human spaceflight distance record, which had been held by the crew of Apollo 13 since 1970. But hitting that apex means the slingshot effect is now active. Earth's gravity grabs the spacecraft and accelerates it back homeward at terrifying speeds. Returning from the Moon means hitting the upper layers of Earth's atmosphere at almost 24,000 miles per hour. The friction at that velocity is extreme. The AVE-coat ablative heat shield has to absorb temperatures hitting 2,700 degrees Celsius, which is hotter than the surface of the Sun. Instead of a steep plunge generating lethal thermal loads, this animated graph shows Orion's skip re-entry technique. It dips into the atmosphere, bounces up, then drops down. This maneuver safely bleeds off excess speed, sheds intense heat, and lets computers pinpoint the precise splashdown zone. The skip maneuver effectively catches the spacecraft, resolving the most dangerous aerodynamic hurdle of the flight. After 10 days and nearly 694,000 miles, Artemis II splashed down safely in the Pacific Ocean off the coast of San Diego. Once the recovery teams secure the scorched capsule, engineers immediately tear into it. They inspect every inch of the heat shield and internal systems to verify everything held up to the deep space environment. The successful return of the crew proves that the deep space hardware, the thermal limits, and the orbital math actually work in practice. The 50-year wait is now officially over. The physical path is now cleared for the Artemis III and IV missions to carry landing craft and plickboots back on the lunar surface. If you want to see exactly how those future landers work, hit the like button and subscribe for our next deep dive engineering breakdown.